Let's learn how to use the Volumetric Lattice feature in Fusion 360. My name's Adam James, and be sure to like, comment, and subscribe for jumping right on it. Before we jump into this tutorial, I did want to give you my opinion on the volumetric latticing feature built into Fusion. Now, I've used latticing softwares that are extremely advanced and complex like NetFab to assist with additive manufacturing for metals and plastics before. And if you're looking for a substitute for an advanced software like that, then the volumetric latticing feature built into Fusion is not a substitute. The volumetric latticing feature built into Fusion provides you a simplistic approach to apply a volumetric lattice to the design at a high level and import it only in Fusion's manufacturing suite. You cannot export the design as an STL file to use in different slicers, and you can't even export it as a step file. The volumetric latticing feature is only available within the product design extension within Fusion 360. Now, this does cost. If you're going to use cloud credits, it's 5 cloud credits a day, or you can pay annually at $595. That's more expensive than I pay per year for the Fusion 360 software. For how much work the volumetric latticing feature, along with some of the other product design extension features need, I wouldn't say it's worth it. And I'll do some more tutorials on some of those features that come within the package as we continue these tutorials later on. But with all that being said, I did want to give you a tutorial and a brief run through at how you can use the feature within Fusion today. Now, as we jump into Fusion 360, you'll notice I have this super simplistic ball. This is just using a revolve and the volumetric lattice feature shown here in the tree. If we right click on this and I do edit volumetric lattice, I just use a gyroid. And we'll go into some of the settings that you can mess around with once we get deeper into the tutorial. The next example we're going to look at is if you looked at one of my previous videos on how to 3D print an air plant bowl, this is essentially what we did, but this is using that same design, but approaching it using the volumetric lattice feature built into Fusion. The next example is going to be doing a multi-body, one being the shell and then the volumetric lattice being the inside of that body. The next example, we're going to go through how to make your own custom volumetric lattice. So this design is just something that I whipped up. We'll understand how you can create your own quick mock-up and then use this custom cell structure to then incorporate into the actual geometry that you're using in your design. And then again, as I briefly mentioned at the beginning of the video, we'll go over how to import it into your manufacturing workspace, because that's the only way that you can manufacture it, unfortunately. So we'll start off with the ball. We'll head up to create sketch at the top left here and left click, and we'll create a sketch on the front plane just by left clicking this plane. C for circle, left click on the origin, and then we'll left click again and hit escape. D for dimension, left clicking on this outer circle here. We'll make this a diameter of 100 millimeters and then hitting enter and escape. Let's go hit on the line button here at the top, and we'll just kind of hover over from the origin until we get to the top and see this crosshair. We'll left click all the way down, ensuring that we have this vertical constraint shown right there, and then we'll hit escape. And we will left click on finish sketch. We will do shift middle click to rotate this, left click on the right side of our circle, or half circle rather, and then we'll left click on revolve. Left click on the axis and we'll left click on OK. Great. So to get to the volumetric latticing feature, we head up to modify and then we go down to volumetric lattice. And it just wants us to select a body. We can either select the body in the UI here, or we can go to the tree and select body 1. And right off the bat, it's already done it for us. Very quick, very easy. A couple of the different things that you can modify within this volumetric lattice window is the cell shape. So right now we're at gyroid. We can go to cross. You could go to 2.5D XL. This is what I used for that bowl design for the air plant, or very similar to it. Schwarz P, and then Schwarz D. So not a lot of cell shapes to choose from, especially if you're paying $595 a year to gain access to this. But Again, it does give you the opportunity at the bottom here to create a custom cell shape based off your own design, which is kind of neat. So let's just keep it at Schwarz D for now. We'll keep it at uniform. We'll keep the size there, and then if we head over to solidity, this just basically gives like your open ratio based off of the cell structure that you have. So higher open ratio is going to have less material and change that structure in accordance to this slider. Pretty neat all the way up until you just become a solid body again at 1. So then we can also move or rotate the lattice. So if you just select rotate, maybe you're 3D printing the structure and you've got some open geometry on the edges and you want to move the cell structure to the left or up or down or at a different axis. That's pretty cool, actually. But one thing it doesn't do is it doesn't give you an optimized or proposed location or rotation for additive manufacturing, which I think is kind of a miss because you could mess around with this all day and then send it over to your 3D printer and maybe you missed one of the sides of this ball and it's just hanging out there at 90 degrees and it's not going to print unless you have a ton of support material, which kind of, removes the opportunity for latticing in the first place. So that's interesting. So we'll select OK and we'll move on to the next example. Next example is going to be just, let's go back here. Actually, we did the ball and then we'll head over to how to create this bowl. So again, left click at the top right here and we'll do new design, create a sketch at the top left. And again, we'll create a sketch by left clicking on this right plane. C for circle, left click on the origin, left click again, hitting escape, D for dimension, left click on this circle here, and then we'll make this a value of 100 again, hitting escape. L for line, we'll do a very similar thing, but we'll go horizontal from the origin, and then left click and left click, ensuring that we stay horizontal, hitting escape. And then we'll do a very similar command by doing C for circle, left clicking on the origin, and then we'll left click again, just shy of the outer circle here, hitting escape. D for dimension, left click on both of these circles, and then left click and give this a dimension of 3. Hitting enter, hitting escape, and then we'll also make one more line, L for line, and then select the origin and the bottom of this circle, and then we'll hit enter or escape. Let's finish the sketch here, and then we will select this sketch profile at the bottom right, and we'll do revolve. We will left click on axis, and then we'll select OK. So there's our bowl. So what we can then do is we'll go to modify and volumetric lattice again. We're going to go to 2.5x cell, select our body, and there we have it. Now we could go to solidity. We can drag this down a little bit if we want it to be a little more open, and then we can click OK. And there's the bowl. Pretty cool. Looks pretty cool in my opinion. But just another way that you can approach that kind of air plant design using the volumetric lattice feature. Granted, this is way more expensive to obtain a design structure like that, especially in Fusion. So let's go back to, we did the bowl. Let's do this box internal lattice. So left click on new design, left click on create sketch at the top left click on the right plane here, and then we'll do create rectangle, center rectangle, and we'll left click at the origin, and we'll left click again, hitting escape, and we'll make both of these equal. So we'll select the top, in the constraints tab, we'll select equal, and then we'll select this top line and this side line, hitting escape, D for dimension, left click and give this maybe a distance of 50. Hitting escape, and let's finish the sketch. Left click on the sketch profile we just made, hit extrude, and then let's make this a distance of 50. Hit enter, and we've got our box. Let's shell this box. So we will click on, left click on shell. Let's go into the tree here and left click on our body. We'll give it a wall thickness of 3. Oh, not 3 meters. 3 mm. and we'll left click on OK. Just to make sure it's shelled, let's do a section analysis at the, what is this? The front plane here. Left click on OK, and we've got a shelled body. Great. Now I'm just going to left click on this bottom surface here, and I'm going to left click on extrude, and then I'm going to left click in the window here at to object, and we're going to left click on the top of the box. Now before we select OK, we're just going to go to operation, left click on new body, so we've got two bodies, and then left click OK. Great. Purpose of this is so that we can reference a different body and it doesn't combine the two bodies together when we're trying to perform the volumetric latticing feature. Left click on body 2, we'll head up to modify, go to volumetric lattice, and bada bing bada boom, it does it right away. Solidity. And I recommend just playing around with some of these processing parameters, right? You can't break the software. You'll learn a lot as you go. And I think it's pretty fun. So definitely feel free to kind of play around with the cell shapes and the proportion limits and the solidity of the geometry. Left click on OK. And then we can turn off this analysis. I just made some like hole cutouts. If this was to be 3D printed, you could go create sketch, R for rectangle, left click. We don't need to be dimensionally accurate here. Let's hit escape. Finish sketch, shift middle click, and then let's just select this sketch profile we just made, give it -3 millimeters, hit enter. Great. You can see the internal structure. So that's really neat, but again, one of the limiting factors of this is, if say I want to combine these bodies, which theoretically should be possible because we've got this solid material on the inside and a solid body on the outside, and they are line to line with each other. If we select body 1 and we control select body 2 and we head up to combine, look at what it just did. It's removing the volumetric lattice from the body. And if we click on OK, and then we tick another cross section, we've just removed all the work that we did. So doing that doesn't actually work. So Control Z to get back to where we were. And just to give you another example, let's take this same structure and we'll take the cube and go on to the next step and see how we actually take this cube and 3D print it, right? Because that's the whole sole purpose of volumetric latticing, unless you want to just render it or you want it for a design. In fact, let's put it to the test. Can we even render a volumetric lattice feature? No, you can't. Oh my gosh, it gets rid of that too. So even if you just want to use volumetric latticing to show off, how cool something looks by shelling it out, well, okay, maybe it populates if we do. No, it doesn't. It's so disappointing. It's really disappointing, quite frankly. So huge limitations here, big misses in my opinion. For how advanced this feature is, it lacks in so many different areas that I really can't recommend it. And just to give you an example, if we want to 3D print this and say bring it into Ultimaker Cura or a third-party slicer, when you select body 2 and then you preview the mesh, it turns it into a cube again. And maybe you're saying, well, don't select it in the tree. Try selecting it in the UI itself. I'll give it a shot. Same thing. Again, big disappointment, and it's a huge limiting factor for preventing you from creating customizable slicing operations in a third-party software, forcing you to use also underdeveloped slicer within Fusion. So really not a big fan. But either way, let's say you did want to 3D print it. What would you do? You can head up to Design and head over to the Manufacturing workspace. Now you have to select your machines. I've already made a video on how to 3D print in Fusion 360. So if you haven't checked that out, be sure to check that out now. But if in fact you have checked that out, let's make sure we're in Manufacture and we'll set up and make sure this is at additive. Okay, great. And I have my machine already in here, and we'll select the body and select OK. Oh, and it wants me to select some print settings. Let's just do regular PLA. Select and select OK. Great, and it's arranged it. Next, let's go on up to New Design again, and we'll go through how to create a custom cell structure for a volumetric lattice. Let's left-click on Create Sketch, left-click on right here, and then we'll use C for Circle again, left-click on the origin, left-click, hit Escape, D for Dimension, left-clicking on the circle, left-clicking again, and then giving this a value of 100. Hitting Enter and Escape, and then we'll do L for Line. We can kind of drag up here, left-click, oops, and this was not coincident, so left-click on coincident, left-click on the line, left-click on the center, and then we can left-click on Trim to get rid of that edge. Left-click on Finish, and we can revolve this again. Left-click on the axis and left-click on OK. All right, great. Now, let's save this as Vol 1, maybe. So next we'll make our cell structure. So let's go up to New Design here. Left-click on Create Sketch. Left-click on this right plane here. And then let's do Center Rectangle. Oh, gosh. Center Rectangle. Left-click on the origin. And left-click, hit Escape. And then let's make all of these sides equal. D for Dimension. And we will just give this a value of maybe 10. Great. And left-click on this construction line, and let's turn it into a solid line. Left-click on all the outside lines by doing Control left-click, and then make these construction. And we are left with a single line at a 45-degree angle that we can now create a construction plane along. Left-click on this plane along path, and then let's left-click on the path that we just created, or the line profile. And then where it says distance, let's just set this to 0. And that will put it at one of the sides of the sketch profile. As long as it's at the far end of one of them, we should be fine. Let's left-click on Create Sketch, C for Circle, left-click on the origin and left-click, hitting Escape, D for Dimension, left-click on the circle, and then 1.5 for this value, hitting Enter and Escape. All right, let's finish Sketch. Command middle click, and then let's select this sketch profile, hit Extrude, and let's make this for extent type. Let's select to object in this drop down. And then we're going to select this point at the bottom of the line that we just created. And then we'll select OK. Now what we can do is now we can pattern this in a circle. So let's go to Create, Pattern, Circular Pattern. And we want to pattern one of the bodies, and the axis we want to pattern it around is this y-axis. And then it gives us an opportunity to input a quantity. So I'll just do 5. Great. So there's the start to our cell structure. I'm going to create another line in the middle here. So I just created a sketch on this right plane. L for line, line all the way up, left click and left click, hitting Escape. And L for line, left click, ensuring these are vertical. Let's left click on equal up here in constraints, and then just make sure these are equal. I want this to be a little taller than the Z height of the cell structure, just to give it something to latch onto in the Z stack. So we'll make this maybe a value of, let's do D for Dimension, maybe 7 millimeters, hitting Enter and Escape. We also want to do the same thing. Let's do it in another sketch. Let's finish Sketch. Construct another plane along a path. And we'll just select this path. Select 0. And sketch on this plane. So left click, create sketch, C for circle, left click, Escape, D for dimension, left click on the circle, 1.5 millimeters, hit Enter, finish the sketch. Let's hide this body so we can select the sketch profile And we will extrude this again, extent type to object. We'll select this point. It says the body is invisible, so we'll show the body again. Make sure that this operation is set to join, and then select OK. Great. And I also want to mirror this feature that I just created. So left click on this extrude feature in the history timeline, go up to mirror, and then the mirror plane, we can just select the top plane here and select OK. And it did not actually mirror that for some reason. Let's see if it lets me mirror. Actually, let's right click on extrude, edit feature. So that's 7 millimeters down. Let's see if we could just do two sides. I'll make this 7 millimeters as well, hitting enter. Okay, great. Okay, and then we're going to create a sketch on the front plane. Left click on this front plane, L for line, and we're going to create a line that's horizontal. Left click, hit escape, D for dimension, and give this also a value of 7. Hitting escape, finishing sketch, and we're almost done here. Let's create a plane along this path. Let's just make this a value of 1. That makes this go all the way to the end of this. And then we will left click on the plane and we'll give it another circular dimension of a diameter of 1.5. Hitting escape, finish sketch, and then we'll extrude this, -7. And we want to do join, hitting OK. All right, now will it let us pattern this around? I am hopeful. It's pattern, circular pattern, axis. Now it looks like it will. I want this to be a value of 4 though. Okay, great, that worked. Let's hide the sketches, and this is our new cell structure that we can then pattern in a volumetric lattice. A little long, a little tedious to get there, but now we can save this as, cell structure. I've already made one, so I'm just gonna call this 3, hit enter. Now let's go back to the ball that we created, and let's open up the data panel, and then let's go to our cell structure over here. Right click on the cell structure we just created, and then left click on insert into current design. Let's do shift middle click, and let's drag this outside of the diameter of the sphere. Left click on OK. Let's hide the control or data panel here. Okay, great. Last step. Let's left click on modify. We will go to volumetric lattice. We can select the body that we want to apply the lattice structure to, but when we go to cell shape, we select custom, and instead of selecting these faces, what you want to do is go into the tree, your cell structure tree, left click on body 1, and boom. Now it looks pretty bad right now, but we can modify that again, right, by going to solidity. So it's only at half volume, so let's bring this slider down, and you can see what we're working with here. I think this is actually pretty cool, and it's unique to Fusion, I think, in this sense, or at least I haven't seen it. And I think it's pretty neat that you can actually do all of this within the software. If you guys found any sort of value in this tutorial, be sure to hit that like button, subscribe, and leave some comments below, and I will catch you in the next one. Thanks.